Now let us solve some question on system of linear equation. In the first question, Ax equal to B has a unique solution. We know that if rank of A is equal to rank of the augmented matrix equal to n, where A is the m by n matrix. So since rank A equal to n, then option B is correct, that is the matrix is non-singular. Now for the next question, 2x plus 3y equal to 5 and 4x plus 6y equal to 10. So if we multiply the first equation with 2, then we obtain the second equation. That is, only one equation is given but two unknowns are there. So one equation and two unknown. Then we know that if this case happens, then infinitely many solution is there. So option C is correct. Next question, if A is 3 cross 3 matrix with rank 3, then Ax equal to B has unique solution because rank is 3 equals to n, where n equal to 3. Now for the next question, x plus y equals to 2 and 2x plus 2y equals to 2. So if we multiply the first equation with 2, then we obtain 2x plus 2y equal to 4, and again the second equation is 2x plus 2y equal to 2. So if we see this, the same equation but 4 and 2, so this is impossible, that means no solution. Next question, if rank of the coefficient matrix equals to rank of augmented matrix, we know that then the system is actually consistent. So rank of A equal to rank of augmented matrix. So at least one solution will be there. Next question, a 4 by 4 system with rank 3 and augmented matrix rank 4. So rank of A equal to 3, which is not equal to rank of augmented matrix, that is 4. So no solution will be there because system is inconsistent. If consistent, then at least one solution will be there. If inconsistent, then no solution. Next question, if we multiply the first equation with 2, then we obtain 4x minus 2y equal to 6. So again one equation with two unknowns. Then we all know that this will give us infinitely many solutions. So option C is correct. You have to remember this always, that is, if you have one equation with two unknown, then the solution will be infinitely many solution. For the next question, A is 2 by 3 matrix with Ax equal to B has a solution. Then the solution is, there is a formula, that is, if A is m by n matrix, here 2 by 3, then rank of A plus rank of the solution set is equal to number of unknowns or number of columns, which is 3 here. So rank of A will be equal to 3 minus, since it is given that Ax equal to B has a solution, then 3 minus 1 equal to 2. So rank is 2, which is less than 3. Hence infinitely many solutions, so not unique. That is, option B is correct. Next question, this is very important question, because a system Ax equal to B is consistent if all of us know that rank of A equal to rank of augmented matrix. Next question, A is 3 by 3 matrix with rank 2 and Ax equal to B has a solution. So rank of A equal to rank of augmented matrix is less than, rank of A equal to rank of augmented matrix equal to 2, which is less than 3. So infinitely many solution. Next question, x minus y equal to 0, 2x minus 2y equal to 0. So that is x equal to y. That is infinitely many solution. Next question, 2 by 2 system with determinant 0. So determinant of A equal to 0, that means rank of A is less than 2. Now there are two cases. If rank of A less than 2, and the first case is if rank of A is equal to rank of the augmented matrix, both less than 2, then infinitely many solution. And the second case, that is if they are not same, then no solution. So in this case option D is correct, either no solution or infinitely many solution. Next question, rank of augmented matrix where Ax equal to B has no solution will be, so in this case since no solution, so rank of A and rank of augmented matrix are not same. But if we take some example, let us take the matrix A with the augmented column. We write in this way. So let us take that in the augmented column, first element, second element, third element all are non-zero. But in the A matrix, first two non-zero, second two non-zero, but the last row is 0, 0. So in this case, rank of A is 0, but rank of the augmented matrix is 3. So rank of augmented matrix is greater than the rank of A. By this example, we can say option B is correct. A homogeneous system of n variables, that is Ax equal to 0, rank of R has nullity. So we know that rank plus nullity equal to n, where n are the number of unknowns. So nullity equal to n minus r, option A. If A is 4 by 5 matrix and rank is 4, then Ax equal to B has, now rank of A equal to rank of augmented matrix. If this happens, then we can say that the system is consistent and solution exists. And since rank of A equal to 4, which is less than number of columns, that is 5, then we can say that infinitely many solutions if consistent. So option C is correct. In the next question, x plus y plus z equal to 1 and x plus y plus z equal to 2. This is absurd, not possible. So no solution. In the next question, A is 3 by 4 matrix and Ax equal to 0 has only the trivial solution. So rank of A equal to n, since unique solution, it is saying only the trivial solution. So unique solution means rank of A equal to n, and that is rank of A equal to 4. 1 second, I think this question is incorrect because here A is 3 by 4 matrix. So rank of A can never be 4. So I think this question is incorrect. I have to check. Okay, leave this question for now. I have to check. Okay, for the next question, A is 3 by 3 system with rank 3 and augmented matrix rank is 2. So rank of A equal to 2 and rank of augmented matrix is 2. So both are same. But this is 2 which is less than 3. So the system is consistent but infinitely many solutions. If A is 4 by 4, det A is not equal to 0. Since determinant is not equal to 0, that means non-singular matrix. So rank is always full rank, that is 4. So unique solution exists. Option B. A system will with more equations than unknown. So we know that if A is m by n matrix, then m is the number of equation and n is the number of unknowns. So there may be any case, maybe consistent, maybe inconsistent. Option C is correct. Next day we will solve some more question.